Hi, and welcome back to the Data Science course, Part 1. Uh, in the first two sections, we covered Python and Pandas. And now we'll cover in this section statistics. Statistics is very important for machine learning. Um all your models use some kind of statistical concept, and the more advanced models will require you to know advanced statistical concepts and calculus and algebra. But as part of the part one course, we need only the basics, and that's what we are going to cover here. The general assumption is, and as a guideline requirement, is that you know some basic school level statistics. So you must have done some things like calculating the mean of a group of numbers, calculating the mode, looking at a distribution of the data as a histogram, but we'll refresh some of those concepts and add some more basic statistical techniques which are useful for building machine learning models. Uh, so what you must remember is that the whole data science field requires a lot of math, statistics, probability, algebra, calculus. But for a beginner's course, basic statistics and probability is sufficient to get you started, start building all the basic models. Once you start building advanced models like deep learning, NLP, then you need to know more advanced statistics and probability techniques and be good at algebra and calculus. Uh, for reference, you can start with the Think Stats book. It's a very good introductory book, has a lot of examples. The structure can be a little confusing, but it's still a good book. Then there's a statistical learning book here, which is very popular, very well known, but it's very advanced, uses a lot of maths and statistics and calculus uh, for teaching how to build a machine learning models. So you want to be careful before you start using this book. You have your basic concepts cleared up. For some basic references, you can use the Maths is Fun website. Similarly, Wolfram, they have some good detailed examples. Wolfram has more advanced explanations, and you can refer them because I mean a lot of students use them, even professionals use them for quick reference guides. So uh, it's a good way to get you started. So you can see here there's a huge guide and a list of all the different useful concepts here. And as part of this course, of course, we'll teach you the basics in statistics and probability. And you can supplement your information with other courses, online tutorials, YouTube videos, and blogs. Let's briefly look at what we'll cover as part of this statistics lecture series. We'll discuss what uh, techniques are used in statistics, and then how do you do the analysis. So let's just see what is statistics. Well, it's collection of data, which is called as a sample, and then analyzing that data using the different techniques. So you need to know what is a population and a sample. So the population is the set of all possible values of that data you're considering for analysis. So, if you are, say, for example, analyzing data for a country, the entire population of that country is the population which you're analyzing, but it's really difficult to collect the data for the entire population. So that's where statistics plays a very useful role is you can take a sample of that population, which is a subset of that data. So let's say you had 100,000 people, you might not be able to collect all the data for all the people. So you take a small subset of people from that, say maybe 1,000 or 10,000, and then analyze that data because you have more accuracy there in terms of the data collection, and then analyze it, and then during that analysis use assumptions to build models for the entire population. So as we've given here, the population is the set of all possible values and a sample is a subset of that data. And remember, it's done randomly. So you don't fix, say, okay, I'll take the first 1,000 values or the last or the middle values. No, you do a random selection. And then using that random data, you can then estimate the characteristics of the entire population by building models for it. So now let's look at the two main techniques, descriptive and inferential. So descriptive is effectively summary statistics for a given sample. It describes what the sample is. It gives information about its distribution and its main properties. So if you remember basic high school maths and statistics, you must have calculated the mean of or the average of a group of numbers. So if you had 100 students in a class and you wanted to know what the average height of that class is, you'd sum it up, divide by the number of students, you get the average. So that gives you some idea of what an average student's height would be. And then, of course, if you drew a distribution, and you will come to that, the bell curve, it shows you what are the extremes in terms of the lower height or the higher height, and where does the bulk of the student population lie. So it's going to be similar, and we'll show you examples how to understand that. So that's called central tendency. You calculate mm, the central behavior of that sample using things like mean, median, mode, and then there is the variability. So that defines, so from the central tendency, say from the mean, how the distribution is spread out and behaving. So you have concepts like variance and skew and outliers. We'll discuss all that in the lectures. And then what about inferential statistics? So descriptive statistics described what the sample is, but inferential statistics is where you actually deduce the properties of the population using that sample by building these models. So what happens is that, so when you took a sample of the population, it has certain information in it which you can capture using descriptive statistics, calculating means and variance. But then now you want to make assumptions about the population used on that sample. That's where you use inferential statistics, and you build models for that. And there are techniques like estimation, hypothesis testing to help you build a good model by going through different iterations, using different assumptions, and then coming up with a sound model of what the population looks like. So once you've created these statistical properties for the population, you want to analyze it to understand the population better. So you have different techniques for that, like univariate, bivariate, and multivariate. They effectively mean how many variables do you have available for the population to analyze. So a single variable population is just like a simple student example where you only know their height. So you want to see how it's distributed, what's the average, and there you can use descriptive statistics. For bivariate, let's say take an example of a simple fruit or a vegetable. You know that certain fruits are expensive in the summer, and some are expensive in the winter. So there is a relationship between the weather and their production and the price. So if you had simple pieces of information like the price and the month, then you can build models to figure out what particular month they are expensive, what they're cheap. And if you added more information like what was the weather like during those months, what was the demand in different areas, or what was the production in different countries, then you can build a multivariate model because then you have a lot more information available about the population of that particular fruit or vegetable. And there you will use different techniques like correlation, covariance, regression. You might have come across them. The another good example for correlation, of course, is inflation and prices. So when things get expensive, we say the inflation is increasing. So there is a correlation between price and inflation, which is effectively as the price increases, inflation increases, and there are other concepts. So we'll cover all this later on. So for multivariate analysis, because you have a lot more variables that you want to analyze for the population, you need to learn all the different techniques. For example, clustering helps you to combine multiple input variables to generate groups and segments. PCA, LDAR, these are principal component analysis techniques. So quite often in the machine learning models, when you want to decide what are the most important variables to describe the behavior, it's not easy when you have too many variables. especially if you're trying to visualize them. So these techniques allow you to combine the input variables in very useful ways. So we'll cover this in the later lectures in the next part of the course when we do the advanced machine learning techniques. And finally, the EDA term or exploratory data analysis is something you might have come across when you were doing data analysis or looking at some data science or machine learning information, which is just initial analysis of the data visually. So it involves some basic summarizing techniques, something which you'll cover in descriptive statistics, and it shows you the basic characteristics of the data. They're useful when you are building a machine learning models because it helps you determine the right algorithm to use for the specific data set that you have. So this is the end of the introduction lecture, and I hope that by the end of this statistics lecture series, you will become familiar with the basic concepts and be able to apply them while building your machine learning models. Once again, welcome to the course and thank you for joining.